Or
I haven't. It's so hard. I haven't bought a new car since 2007.
okay,
And the combined age of my vehicles presently is, let's see, my truck's an '05. So what's that? 18 years old. My wife's car is an '09. It's
okay,
15. And my son's car is the newest one, 2014. So it's 10 years old.
okay.
So I can't do math in my head when I'm on the spot like this, but what are they? It's over 20 something years old.
Close to 30. Yeah, 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 definitely.
Yeah.
Wow.
So buying a new car. I'm kind of curious to if it's time to get to go electric or not.
Ooh.
Because it's been so long since I've bought a new car. Is it time to just because I plan on keeping the thing, I'll keep it for 10 plus years.
Yeah.
So is it time to do it now? What do you think?
That's a very good question. Where you live definitely matters.
Yeah.
So, I'm here in California, so electric is, one of the big things that's been happening for a while. Tesla is just everywhere.
All
You
right.
literally see Teslas driving everywhere. Um, See, I mean, okay, and talking about gas prices as well. I mean,
Yeah.
California is
That's
just
not a factor for me. So the cost, like fuel cost, is not really a factor. It's more of just, I don't know, the cool factor, a little bit with environmental, I guess. But mostly I really am curious of like how quiet they run and how much more efficient the engines are and that
yeah.
that sort of thing. But
The funny thing is, I mean, it's. I was reading this article somewhere where they say the electric cars are so quiet that they're running the cats and the dogs are running into them on the street.
wow, that's a good, yeah.
So that's
So there's like a unintended consequence there, huh?
there is, and I mean, of course, electric cars are the future, and that's where the entire world is sort of heading as well. And
Yeah. Well,
making that move.
like is what do you think else is going to happen within the next 5 to 10 years with electric? You think it's range or
So
what other?
range, battery life, that's like, one
Mm,
of the issues that are running into these days. And of course, the size. The main thing is to be able to kind of get this big battery into a
yeah.
little bit in a smaller area.
Okay.
So that's where most of the battle is happening when it comes to, like, the battery companies. And but I mean, there's a lot of research going into it. So I can only imagine, like, if I can only imagine in 5 years they will be able to achieve somewhat, get close to it, and get better range, faster car, faster cars, because I like fast cars. So
Mhm.
so so yeah. I mean, the future for battery cars is fantastic, and electric cars is, of course, like, fantastic. But I think for everyone to move all electric will take some time. So,
Yeah.
and that's where it comes to hybrid, right? So you've got the
Yeah.
cars that are like half and half, and you can utilize both sides. So I think that would be a good way to go to start entering into it, if you still love, your petrol car noises, and and still want to step with the technology and use the latest and the greatest. So I think, if I was you, I would go with the hybrid route.
Would you?
But
Okay. Okay. Maybe I should consider that. Hey, if you're in the chat and you're joining us here, yeah, weigh in on this. Would you, if you own an electric vehicle, which kind? Because I'm looking for some advice on what to look at, or maybe I'll take Ronit's advice here and steer more in the direction of a hybrid, or I don't know. Do I just pay for gas? It's not expensive here in Nashville where I live. Should I just stick with the status quo? I'm not sure. I need some help on that. But
Is it going to stay that way, though, in the future in Nashville? I mean, is the gas going to stay that way? What's going to happen? We never know.
yeah, who can know? Well, it's a puzzle. I don't know. If you're like me, you always I feel kind of paralyzed due to analysis. Like there's just so many choices out there what to do, and you don't ever want to have to go buy a new car or have to buy a car because of a maintenance problem or something like that. So I don't
Yeah.
know, kind of a dilemma. But I guess hey, Ron, thanks for the advice. I'll look forward to maybe getting some good advice out of the chat here. But Hey, welcome everybody to Live Design. My name's Brad Williamson. I'm your host today. I'm one of the industry process consultants here at Dassault Systems. And I'm excited for this episode today because we have my friend Ronit Mukherjii. Ronit, did I get that right?
Man, you nailed it. Brilliant work. That's amazing.
So Ronit is here. Now, Ronit is my teammate on the digital technical sales and marketing team where we work and has been on our team for a little while now. But he has a really interesting sort of past life. He brought a lot of really good industry experience with him, especially as an FEA analyst and product designer. And so the episode today, Ronit, I believe, is about your day in the life, or kind of you're walking us through some of your experiences in the real world as an FEA analyst, and then I think you're going to relate that to some of the simulation tools that we offer and how you've made use of those. Did I get that right?
Absolutely. Yeah. Fantastic job. I mean, we're good to go, guys. Thank you for laying down that for me, Brad. But hi, everybody. My name is Ronit. Thank you for that mention, Brad. I am on the DTSM team, the Digital Technical Sales and Marketing team. And the products that I am in charge of is the cloud simulation tools. Super excited to be here, Brad. And yeah, like I was telling you earlier, there's a lot of stuff in my brain that I wanted to kind of get out. And as an FEA engineer in the industry, and I've been there for a couple of years, and then I'll actually go back a little bit. I'll tell you my journey, how it all started, and how I got to be the FEA engineer, and how I'm back here at DS. So I was lucky. My path was a little bit non-traditional compared to a lot of the engineers that might graduate from college and then go get an engineering job. So it was a little bit different. I got my first role out of after a few internships at a channel partner of SolidWorks, and I started as a technical support engineer. So I just deep dove into all the tools first. So I learned everything about the tools, and I still learn everything about the tools. I still keep on learning, but it's when you're answering a lot of calls, a lot of emails, and you're getting the engineers go past that stuff they're stuck with. You kind of learn the tool on that way. So I was in that tech support role and an applications engineer role for 4 or 5 years, and then sort of shifted gears a little bit and went into the software world as an account executive. Tried to learn, how the software side works, and being the liaison between, my technical team and the client's team. So a lot of learning experience over there as well. And then I shifted gears again, and I went into the industry, dove in headfirst into medical device, and started learning everything, how the actual industry works. I have a lot of knowledge on how the tools work. And of course, I've done some consulting work here and there, but when you're working in the industry and you're facing those challenges on a day-to-day basis, it kind of opens your mind as to wow, there's how some of these tools that I've used in the past, how they can help me in my current role. So
yeah, what was maybe one of your most surprising revelations from going from, say, a product expert to a product designer? Like, you were an expert in using the tools, but now putting that to actual use with real project deadlines, where it's not just about software anymore. You have so much more to consider. What was maybe something really surprising to you in that?
I would say the most surprising thing to me was the lack of tools, man. There was just lack of tools in product development, and it just blew my mind how we can create a product and go into the product development process and work with all the vendors and stuff, and you haven't run any analysis on it. What? That did not make sense to me, right? So knowing the tools, I'm a big vocalist. I love the tools so much because I see the value that they've provided me over the years, and then it's my job to let my peers know about these tools. So lack of knowledge was also another aspect where folks didn't know that these tools exist.
Yeah.
And that lack of knowledge that's where we come in, right? That's where your the champion engagement partners and people that work with VARs, and even in your company, if someone is using the tools, they're more interested in learning about more tools but yeah, you have to uh, describe the case to your boss. Is it why we need these tools, right? So for simulation, it's a little bit easier because the value you can show what these tools bring is just very impactful. So that to answer your question, Brad, yes, lack of knowledge and lack of tools was that was the most surprising thing that I ran into when I went into the industry.
Yeah.
And yeah, so
Well, that probably then that's where you really added some value, I would imagine, right away, is just being able to recognize that and then be a champion for a solution.
absolutely, absolutely. And when you look at when you're looking at a product design, any product can fail in multiple different cases, multiple different scenarios. It can fail. So you really have to kind of look at from from an outside perspective. Like, okay, I'm working on this product. Okay, it has some plastic components. It has some electrical components. It has some like metal components. What are the different ways this can fail? Like, you start thinking about that, and then your mind, and knowing that you have tools that can address these different issues is critical.
Mm-hmm.
If your team or your engineering team just doesn't know, okay, let's take an example, like, a simple stress analysis. Yes, that's a base level stuff that every designer should be doing. um, but that's not the only failure mode, right? There's multiple failure modes that a part can fail. So you want to take a look at all of those, and you can only take a look at all of those when you have all those tools, and preferably in a collaborative environment where you can address these tools, and you can reach out to these tools and get your answers out before you're even going and making a single prototype.
Yeah, makes sense.
That's
So
the
I'm guessing you have some examples to show us today of some use cases and some examples
Yes.
from your expertise.
Yes, we'll work on some use cases. We'll show
Okay.
some studies that I've set up. But wanted to discuss a little bit about, like, what an ECO process in a medical device would look like. If you're working in the industry, and some of the challenges that come along with it. So, and not just in the medical device industry, in any industry. So, and this whole product development process is filled with change orders, filled with change orders. You start a product, you have multiple components, and you're going constantly going to make changes into it, and every change that you make has to be recorded, addressed, justified, and approved by multiple different departments. So you know any medical device would have, let's talk about the different departments you'll have, Brad, in a company, in a medical device company. So what are some of the departments you think you'll have?
Okay. Well, obviously R&D,
Okay.
engineering. Were those separate in your experience?
Most of the times they can be combined
Okay.
together,
So
and then you can
R&D
separate.
engineering. Well, then you might have testing might be separate from engineering. I'm not sure if production and testing might be a different department. Manufacturing, whether it's in-house versus or you use outside vendors. Then, of course, you've got sales and marketing. Would have a big impact. You probably have a big legal staff that has to deal with regulations. Those are just the ones off the top of my head. What have I missed? I'm sure there's a
Nailed
lot.
it. You nailed most of it. So over it, I took a little note down. So you've got mechanical, electrical, you've got software. So you've got these, you've got a PCB, and you've got a software that's running everything behind it. So you've got a software team, you've got a manufacturing team, you got regulatory, like you mentioned, doc control. Like, there's a doc control team that's managing all of your documents. Like, every ECO process, you're gonna have that. And you also have shipping and warehouse. You have a team that's in charge of allocating lot numbers, and taking in shippings that are coming in. So you have that's a whole different team as well. And every time you make a change, you have to make sure that every single department approves that change. That takes time, man. That takes time. That's so you want to make sure these changes that you're making are less and less. You want to be able to analyze your changes before you make them, and before you go to the ECO process. That's
Okay.
like, that's the key.
Okay.
And one of the other challenges that I ran into when when I was working in the industry is, okay, so let's talk about the mechanical, electrical, and even software and manufacturing. All these four departments will be okay using the tools, like, well, okay using, let's say, design tools or simulation tools or electrical tools or things like that. But every other department, they're not okay using SolidWorks. They're not okay using simulation tools and they don't have to, because they're not running any analysis, they're not running any design work and stuff. But they
Yeah,
need
but
to.
they depend on the data,
Exactly.
whether
How
it's
do
an
you
image, a PDF, a drawing.
Absolutely. So how do you deliver the data to them? They don't
Okay.
have SolidWorks licenses. They don't have, simulation licenses, but they need to see the results. They're a part of the ECO process. And if you're justifying, hey, I'm changing this component's size to this because it's breaking, they need to see that results to be able to approve that ECO for you, right?
Okay. Okay.
So
And
this is
like Sean is
sorry,
saying here, time seems like a huge factor. And by the way, if you have any questions for Ronit as we go along, just toss those in the chat. I'm going to keep an eye on things as we're conversing here. But Ronit, if time, how big is time in something like this?
So that's a brilliant question. And I want to emphasize on, like, when everyone says you're saving time and you're saving cost, you really don't pay attention how much time you're saving. I'll just give you one example and we can like extrapolate from that. So let's say if you're working with a mold maker, okay, and you've got a plastic component that you have to go into high volume production, and you're working with the mold maker and you send them, your plastic part. You didn't do any analysis on it. You just send it to them because you're expecting them to do everything, right? So the mold maker comes back to you after a few days because you're not the only job that they have. They have 20 other jobs lined up. So, and if you want to be the top job, you got to pay more. So that's all that goes in real world. So the mold maker comes back to you after a few days and goes like, hey, by the way, these ribs are too thick. You need to make a design change to be able to address this. Like, right. And now you go make a design change. That's an extra couple of days. And then you send the results back. Then extra. It just happened. 1 week just went by.
Mm-hmm.
1 week went by and nothing has happened yet.
Nothing happened.
Nothing has happened yet. And this happens again and again and again because now is the rib. Sometimes going to be something else. And just because the first run they did, there's going to be some other problems that pop up. So what I'm saying is the value the simulation tools bring in saving that time is just too much. Like without these tools, it's to me it's like insane, like how you cannot have these tools before while you're doing the development process and you're only banking on somebody else who's a third party person who's telling you, okay, you can do this and you can do that. So I want to have a little bit control over my design. So I want to be able to make sure that what I am sending to the mold maker is first pass is really good. I'm not having sink marks. I'm not having A traps. I'm not having shrinkage issues and things like that. So
okay.
That can only be done with these tools.
All right. Do you have an example?
Yes, I do. And I'm about to jump an example, but before I do that, I wanted to show this. The reason why I was bringing, these tools are not for everybody. Like regulatory doesn't want to use it. Dog control doesn't want to use it, but the web browser is for everybody. Like, the web browser that we have, everybody loves a web browser. They can access a web browser. So I want to show you, Brad, what I have over here. This is my platform. This is my dashboard. This is what I'm working on right now. It might seem too much, but let me give you a quick little rundown on what we are looking at. Okay. I've got a couple of different tabs up here. Okay, so this is my whiteboard ideas tab. I've created this tab where I've got a lot of information in my brain, and I like to throw it down so I do not forget about it, or I can come back to it and things like that. So this is where I kind of jot down all my information and things that I want to work on eventually, and just some random ideas. Now let me take you down. Let me take you to this content site. So what I am working on is this bowhead model. So you must have seen, our team created these fantastic videos of what's new 2024. This was the model that was used.
And, yeah, that's our customer Bowhead in Canada, and they make they make these off-road cycles for people with IDD or with any kind of physical limitations.
Correct. And
Oh,
I
wow.
mean,
You made some mods to this. This is cool. I wasn't
so
expecting to see this.
I mean, surprised, right? I wanna make sure you're surprised on this one. So I want to actually kind of show you what I've done in this dashboard and how I organize myself, and then I'll jump into some simulations. There is an issues tab. So when we were looking at this model, when we were looking at this entire bowhead model, we tried to dissect it in different places and trying to understand how different components will act and how different components will behave when we run it through some simulations. Starting with just basic swing arm design. So that's all. It's all starts with one design, and then eventually you make revisions and you update, and there's a whole process till you get to a final design that you like. So, and when you're working in a team, Brad, let's say, okay, if you're working in a big company, you're going to have one person that's an analyst. You're going to have one person that's a designer. You're going to have a couple of people that can do a few different things, right?
Yeah,
But
lots of contributors, sure.
lots of contributors. But when you're working in, somewhat of a smaller company, you don't get to have that luxury, and you just have to wear multiple different hats. And sometimes the designers are the analysts. And I actually like that. I want the designers to be analysts because now you get to design. Now you get to design and analyze at an early stage.
Okay.
Whereas an analyst, if you think about what their role is, an analyst gets the design to be analyzed when it's almost like towards like the end. Hey, we've done all this great work. Hey, can you analyze this and make sure it works? I believe that's a little bit wrong approach. Like, we need to be analyzing these things as we are building it. So if I'm making the swing arm, I want to analyze the swing arm and see if it works well or not. Okay. So I have a few different tasks that were given to me, or issues you can call it, where I can select on one. It gives me all the information about what I want to do or what I have to do over here, right? So this is a two-piece swing arm. Sure. Stress and fatigue test. So just like that, I have different tasks that I've created based on this bowhead model, all the things that I need to do to address all the different areas. So I have a comparison between a two-piece and a three-piece swing arm test. I was talking about this plastics design. I want to make sure that this plastic design is good to go. And then there's an articulation bracket, a fatigue type issue that I want to talk about. So there's all these issues that I've created in an organized manner. If I show you this data grid view, I can see what's to do, what's in work, what's pending approval, things like that. So it kind of gives me a little bit of structure. Man, when you don't have this kind of structure and you have to go back into your emails and this and that and kind of see what you have to work on. I used to write this on a Word document or a sheet, all the things that I have to do. But
yeah, I'm trying to think how well, and if you work in an environment like this too, where you're managing these multiple tasks and within a project, how do you keep track of those? I'd be glad to hear from folks in the viewing audience here how they're doing it. But yeah, the first thing you came to mind was like, well, I'd make a Word doc, or probably an Excel spreadsheet would be my go-to if I didn't have a tool like this.
I used to scribble it on a paper, and I would go back.
Yeah, or sticky note.
Yeah. And I could not recognize my own handwriting. Or sometimes I was like, oh my God, what did I write over here? Is that a 9 or a 6? I can't tell. That happens, So this has given me some structure, and I really like it. So I have issues, I have tasks, I know what I need to do. I know the priority on it, and I can address it as I go.
Okay. So which one are you going to tackle here first?
I'm going to show you a bunch of them. So this is just issues. So now let me take you to the simulation tab. I have addressed, or I've started working on some of the simulations. Some of them are completed, and I don't want to go search for it again and again. I don't want to go hit that search in a demo and look for what that simulation is and where it is and find it. What I've done is I've organized all the simulations that I'm working on in this bookmark editor, and on the right hand side I've got a review. This is like a lightweight results review that you can use. And so we were talking about that, the swing arm test, the 3-piece and the 2-piece.
Yeah, 3-piece versus 2-piece.
Yeah. Okay. So so I've run these studies, and I can open this down the road. But like I was telling you, like, the dog control and regulatory, those departments, they don't have those tools, but they have this. Like, they can have, like, bookmark editor, they can go take a look at some results, they can take a look at some screenshots and stuff like
Mhm.
that, and they can approve their ECOs and get the results that they're waiting on. So just a follow back to that one. But okay, so over here, I just opened up the 3-piece swing arm assembly in a lightweight results. I can take a look at, like, what my displacements are. I can take a look at what, my von Mises stress is, and just kind of do some type of, like, lightweight post processing, I would say. Um, you see how, Brad, did you see how easy it is for me to, like, you just drop that study over here and just
Yeah,
kind of
yeah,
look at
drag and drop.
it? Yeah, same. Like, if I wanted to take a look at my plastic study, if I run it, of course, it's going to show up over here. Now I can take a look at some.
Okay, here we go. So I'm looking for things like sync marks, and I think I saw
So
fill time there.
so this is a very lightweight. So let's see what we are about to what we can see in this case. So in this case, we can see some pressure, some fill time. I can see some pack and cool,
Oh, wow.
and I
Okay.
can also see some warpage. So I did create, like, a warpage study as well. So when this thing cools, when this plastic components cool, how it's going to shrink, and so I have the ability to take a look at that and
Yeah, animate it for the people. Look at that.
animate it. Here you go. Of
Okay.
course. So again, all of this is lightweight. I have not opened any tool yet. That's powerful, Brad. That's very powerful. I don't have to wait for licenses or anything like that. I'm good to go over here. Now, for the ones, and so when you're an analyst and you're running these simulations, of course, you're going to have some meetings that you're going to sit in, and you're going to explain to your team and your bosses why, your analysis, what you've done, what you figured out. And for those people, like, in their own team, you can actually deep dive. I can open any of these studies and see what was done. So let's take a look at something. Let's take a look at
Okay,
yeah.
so you're now you're in the simulation tool here.
Right, exactly. So if you notice, the window changed. Now this is my simulation tool.
Mm-hmm.
I've opened the simulations that I showed you. I've pre-opened them because it takes a little bit to open and show results. So I've
Okay.
already opened it over here for us to take a look at. So let's start with this simple, like, a 3-piece structural analysis that I ran on this swing arm, and the goal was to just figure out if this thing is going to work or not. Like, if this thing is going to fail based on, like, what loading conditions we have added. And if you look at your factor of safety or your von Mises stress,
Yeah.
that's you're good to go. You're going to be fine. Like, von Mises for the 6061 is way above 91.5,
Mm-hmm.
and
Mm-hmm.
that's the max we see, and so we're good to go. In fact, some people even would argue that this is overdefined. So that's also a case, Brad, where a lot of the times where people don't have these tools, what they do is they just go ahead and overdefine everything,
Sure.
so
Over
it's not
design
going
it.
to fail.
So
Yeah,
factor safety, what is that
like
for
I
real?
said.
50? 50
So
is
no. So factor of safety in this one is way high. So
way
even
above. Okay, and
way
then the
above
minimum
50.
is
Yeah,
what we
yeah.
want to look at, right?
Minimum, yeah.
Okay.
Minimum is what you want to look at, but also when you're looking at the minimums, you want to take a look at, if there's any stress hotspots it's showing, things
Okay.
like that. So it's a whole post process that goes into it. But at a very, very early stage, Brad, this can give me an idea if this is going to work or not.
Mm-hmm.
Let's say if this is not working, and if I'm moving forward with this down the road, it doesn't work, then I have to come back all the way, and all the changes that I've made gets, like, trickled down.
Okay.
So
Hey,
you want to
Ronit,
make
I've got a question for you, and
sure.
maybe somebody in the audience has this as well. But if I'm used to seeing stress plots, I've worked with a lot of simulation tools over my career, but I'm this where you're seeing the gray. I'm used to just seeing, a rainbow between red and blue. What's happening with the gray?
That's just something that I've kind of updated or moved, things like that. So the factor of safety is so high that I had to change, like, the color coordination for it to bring down.
Wow,
And
that's really
that,
cool. So it's anything above like a crazy, it's everything that's just like super, super above.
correct. Or what you can do is you can also create sort of an ISO plot where you can define two values, and it will show you the value in the middle or outside
Yeah.
outside those values. So you can create those post-processing plots, absolutely.
Okay.
Um, but what I want to also talk about, like, Brad, I was saying, stress is, a simple linear analysis is not the only place where we stop. This thing
Mhm.
can fail in multiple different scenarios, right? So, another scenario that could be like, since this is a swing arm that goes on an e-bike, it's going to go through so many bumps and there's going to be random vibrations that are happening. Is this thing going to be able to handle it? So you want to learn these things. You want to understand how your swing arm is behaving during random excitation,
Yeah.
and depending on that, you make your design changes or not. So if you're okay with that, it's great. So what we can do, so with this portfolio that Dassault Systems offers the 3D experience simulation portfolio, we've got multiple different roles that can address not just simple linear static or nonlinear studies, but really high level, like random vibration, explicit analysis, where you're like crashing things and seeing how things break down when or drop tests, things like that. So you have multitude of different, like, multi-physics type of capabilities to address different failure modes in your design, basically.
Mhm.
One of them over here, so I took this study to the next level, and I created like a random vibration study from it to understand, like, the RMES's stress results. So just to show you what I did, how that, what that setup sort of looked like, I want to take your attention to this structural analysis case that I created for this three-piece swing arm. And down here, the first thing we do is create a frequency step to understand all the mode shapes,
Okay.
and based on that, you create a random vibration study. So uh, let me just open that up. You define your upper and lower boundaries. You define your critical damping fraction and your modes. So once you're done with that, and of course your frequency scenarios, this might take a little bit to show results. Let's see if it pops up. Okay, it does. So once you have that, man, you can take a look at your, like I mentioned, your RMES's results and stress values, and see how at different. Okay, why is it not opening? Let's give me 1 second. It's not displaying for some reason my dynamic results of, or sorry, random vibration result, but it's showing it over here. So, but it's fine.
Mhm.
So over here we can take a look at different modes that we have created, and the RMS is corresponding to that particular mode shape, or that particular frequency, actually. So again, we're not just stopping at static stress or nonlinear stress. We're taking it to the next level and understanding
Mhm.
how random vibration works. So we
Okay.
have those capabilities. And let's talk about another mode of failure, Brad. So this is
Fatigue would be next on my list.
that's it. You nailed
Yeah.
it. You nailed it. So I'm just going to switch back to a different component, different this articulation bracket, which is a part of. It's actually a pretty big piece of bracket that goes under the bowhead bike,
Mhm.
and there's three of these, and there's a lot of load, like almost the entire loads on the front, and the rider load is acting on that. So when you run a linear stress on it, yes, that works fine. Like,
Mhm.
the material that you're using and the loads that we have created, things are great.
Well, and
But
that's probably why a lot of times we over design with large factor of safety, is because we don't have the luxury of doing a real fatigue or a virtual fatigue analysis.
absolutely,
Yeah.
absolutely. But when you are doing that, when you're over designing, there's a few things that you have to keep in consideration. You have to also see what over designing does to your parts, or to your entire assembly, and you also have to look at the logistics part of it. So now let's say if you're over designing an entire assembly
Yeah.
and you have to ship this thing, like, back and forth to your customers, this and that, man, the logistics costs, the shipping costs, all of a sudden you're like, things are bumping up. So you should be able to address, over designing your components and stuff using these tools.
Okay.
Why do we need to over design it? Why do we need to make things so heavy and clunky if they don't need to, right? So same scenario. So over here, this articulation bracket I was telling you about, structural analysis works great. But what happens to this in, let's say, 5 years or in X amount of cycles? We don't know that. Like, we want to be able to predict what we can do that, right? So for that, we create a fatigue study. In this case, we create a durability study using our FGM role. And you just define your conditions. You define your fatigue loading, and let me jump on it just to show you what you can
Yeah,
do
yeah.
with
What's the
loading.
I'm curious about that. What's the load case here?
So load cases can depend. So when you're doing a fatigue, oh, actually, this let me also show this quick um, um, video. So have you've been on planes, right?
Yes, lots of them, and I like it less every time.
Okay, so I'm sorry to show you this. Maybe I'm happy to show you this because this might make your fears a little bit ease. What you're looking at, Brad, that's the wing of a Boeing or Airbus. And I want to show you what they do to test this for stress. Like, okay, can you see that at all? Okay, never mind.
Yeah. Okay.
Okay, so let's just say we cannot. So when you're testing the wings of those Airbus, they are putting it through tests like lots and lots of cycles, and they are flexing this wing all the way onto the top, all the way onto the bottom, all the way onto the top, and they keep doing it. They keep doing it. They
Yeah.
keep
Yeah.
doing it. And
Okay, I can imagine that. And I think we have to diverge from the video because of some copyright.
Okay, cool. We can.
But we can imagine what's going on there.
Perfect. So what you can do over here in the loading cases, you can create those scenarios. You can create, so let's say if there's a certain type of load acting, on the wings or in this case on the side, at a certain amount, like, certain newtons. And then you have another load that's acting at a certain angle at different newtons. So what you can create is you can create, sequence of frames. You can create like superimpositions where you can tell like the software, hey, this structural load is, scale it 10 times or apply it X amount of times, and, just apply it in this particular, and apply it to that particular increment. So you can create multiple of those sequences. So I can create another one. I can create some superimpositions where, I'm basically superimposing like, the loads that are happening. So so what you want to do over here, Brad, is you want to be able to create that sequence that's realistically depicting like, what's happening in your model. Does that make sense?
Yeah. In fact, I hadn't heard that term in a while, but now you're digging deep into my hard drive. The superposition of load cases. Okay. Yep, I remember that.
Correct. Okay. And and then running the study, and of course, the software is able to tell you, the log of life, like, how many cycles we'll get out of this. And you can already see down here, the minimum log of life, the minimum cycle is 3.11, so 10 to the 3. But if I do a little bit more digging, I can see that maximum is happening on that edge. So this might just be a hotspot. This just might not be a realistic value to look at. So I'm looking at an overall thing. I'm looking at like, in this area, the green, yellow, blue area, that's what's like, kind of like what's happening on these edges. So I'm gonna say like, the log of life is around like, 10 to or of 5.5. So 10 to the 5.5, whatever the number of cycles.
Okay. Yep.
Again, a quick analysis was able to give me this value, right? If I'm not happy with that, if I'm like, oh my God, that's not enough cycles, I need to bump it more. So what we can do is, I can jump into my SOLIDWORKS design right away. So I can just select from here, go into my SOLIDWORKS, make that design change, and bring it back. And of course, just hit one update, refresh, rerun the study, and you're good to go. Yeah. And now with the updated results, I can, verify, okay, now my log of life is, better. And now this particular bracket is not going to fail at X amount of cycles. It can go up till X times whatever.
Yeah, that's an important point too that you bring up, is that when you do make that change in the design, if I hear you right, it just updates immediately in the simulation environment. It's not like an IGES or a step output. It's the native geometry.
Correct. So of course you have to be you have to hit the update button in the simulation world, so it can connect to where this part is coming from, where the information is coming from. And once that happens, yes, it's
Yeah.
good to go.
Well, you
So
know what
yeah,
else is really good about that too, I guess, thinking about from a data management standpoint, is you don't have like two separate copies of, you know, a CAD model and then the CAD model that you use for analysis. They're the same. It's the same piece of data.
right,
Okay.
exactly. So you know, there's it's funny. I love exploring tools, Brad. I want to see what we can do, what's happening with, like, you know, the new technology, and what's happening new in the world. You must have heard, like, you must know this, where in the recent years, metal 3D printing has just kind of taken off. Like, everybody's interested in metal 3D printing, or
Yeah.
to lightweight components and things like that. You know, so I wanted to see what we can do with lightweighting, and we have a tool. Did you know we have a lattice designer tool?
Well, yeah, I've seen, I haven't, I would like to know more about it, but I
Okay,
do know we have that. Yeah.
I was super impressed. I learned about it not too long ago, and you know, so I was like, okay, let's see what we can do with it. So I want to do, like, the swing arm design is a little bit easier. So I wanted to
Okay.
kind of have like some curved surfaces and see if I can create a lattice between the two, like, you know, between over here. So
Okay.
I've done it. So let's do a live thing. Let's see it's going to work or not. Sometimes it does, sometimes it doesn't. So I'm going to risk it, risk my credibility and everything, but we'll give it a shot.
Now this is familiar to me. You're in SolidWorks.
Correct. So simple SolidWorks. On the right hand side, I'm connected to my 3D Experience platform and
Mhm.
all the tools that are available to me, or that, you know, that I have.
Yeah.
One of those is the Lattice Designer tool. And under Lattice Design, I'm going to just launch the tool, and hopefully it opens
Okay.
up.
Live demos. Live demos, everybody. Anything could happen.
Okay, see, it's so I've got a new login that I have to go. Let's let me see if I need a new login. If not, then we can of course take a look at the plastics. All right, come on. All right, we'll come back to this. We'll come back to. I'm gonna
Okay.
have that just set up in the background, so we can come back to that if that works. If it doesn't, then I definitely have something to show you with the results. All right,
And so the Lattice Designer, is that simulation? Is that a simulation specific tool? Question coming from the chat here. Is that simulation specific?
No, it's a design specific tool. So it's a CATIA tool that allows you to create lattice designs
Yeah.
using your mod. So okay, there's another thing. So right now that tool is more compatible with X-Shape, or actually it is
Mhm.
compatible with X-Shape. That's where we want it used as well. But I
Okay.
figured out a way how we
Cloud
can use
design.
the SolidWorks, you know, models into Lattice as well. So that's kind of a, so sometimes it works, sometimes it doesn't, because it's not supposed to be used that way, but I'm still trying to
Yeah,
use
it's
it that
still,
way.
yeah, still
So
evolving. Some evolving technology there. That's fine.
yeah, evolving technology there. So, and over in the next, you know, I'm sure in the next couple of updates, it's going to, you know, it's going to
Yeah.
be in a good,
Okay.
very, very good
But in
place.
answer to the question, it's when you design a lattice, it's not reliant on a simulation. It's a design, it's a design tool first.
Correct,
Okay.
correct.
Makes
And
sense.
then I wanted to take it the next step. I wanted to bring that lattice design into
Yeah.
simulation and run some analysis on it and see, you know, what the stress value sort of looks like. And yeah, it's got some
Yeah.
cool results if I'm able to open it. But so this is all structural. I did want to, you know, mention plastics again, because to be honest, Brad, that's such an underrated tool. Like, this tool is so underrated, I can't tell you, because I went through the pain of interacting with mold makers on a
Mhm.
daily basis and the changes that we had to make. And if we had this tool, then, you know, I can just say we would have saved a lot of weeks just interacting back and forth and waiting for our job to go up on the number one platform, and then go into the machines and stuff. So
Well, is the
um,
tool, is it somewhat guided though? I mean, like if you're not a plastics engineer, are there some things that you can still do that maybe put you ahead of the game when you do submit for tooling and those kind of things? How does that work?
absolutely, it's one of the easiest tools to use. Very, very easy tool to. And let me just quickly kind of go through it with you. So
Yeah, let's see how that works.
so over here on the right hand side, you see the assistant panel. That's going to be your best friend. You
Okay.
start at the top and you go down one step at a time. Okay. So the first step is asking you what's your contributing parts? What parts do you want to run? So I've got this plastic part. So when you click on it, it's going to ask you to, select that part. So let's say, it's going to ask you, hey, this is the part, select it, and what can you do with it? So you have a few different options, Brad. So you can run it as a plastic if it's a simple plastic. You have a hot runner, cold runner system. You can do insert parts. You can do coolants, mold inserts, a lot of different options right here. So,
Okay.
but this is a simple plastic part. I just want to see as a simple design engineer, I want to see if this component is going to even fill properly, or if there's
Okay.
going to be any defects on that, right? So I select that, then I go to the next step. Next step, it's asking me to select a material. We've given you a library of tons of plastic materials that are from the industry. So industry standard plastic materials that you can select from. Of course, I forgot to hit refresh, so I should probably do that. Let's see. It takes a little second to pop up, but
Okay.
come on. Yeah, it's thinking and thinking and thinking. Okay, come on. Okay, well, you get the idea, Brad. You've got a material palette
Yeah,
with lots
materials.
of
Got to
materials.
have that. But
It's taking a lot of time because there's a lot of materials in there. So maybe I can cancel out of it. Okay, great. So once
okay.
your materials is set, then you go into your process settings. Okay, what are your process settings? Basically, what's your mold, melt temperature, mold temperature, and if you have any, field simulation information like pressure limits and switch points, things like that, you
Okay.
can add. But
Okay.
I'll keep it at default. Most of the times, as an engineer, you want, as a design plastics engineer, you want to keep it at default, and you just kind of hit OK to that. Next is your conditions. You want to tell, or you want to tell the software, where does the plastic enter into my mold, or where would that location be? If you have enough, plastics knowledge, yes, you can perhaps, start picking on areas that you think is going to be good as an injection location, or just use auto location,
Yeah.
and it's going to choose the best location for us. That's what I do,
Okay.
and
That's what I would use too.
it has never failed me, Brad. It has never failed me. So, and of course, you can define some valve gates, coolant inlet and outlets. So you have some other options. That's it. You
Okay.
just simulate after that.
All
Click
right.
simulate, and once your results are done, let's take a look at some results.
Then would you ever like this is going to give us a really good like first pass, I would guess, right? Just taking some rough guesses of a few things, or not so much guesses, but some defaults and things like that. And this is going to get us closer than if we hadn't done anything, for sure, right?
Absolutely. So, just a quick post process. I can take a look at wet lines. I can take a look at sink marks. Like now, you notice this area. Oh, kind of jumped on me, but this area is pretty thick.
Okay.
And when it is thick, you are going to see some sink marks on it when the plastic cools. When the plastic is thinner somewhere and thicker somewhere, you will have different rate of cooling. So you'll see some marks which are aesthetically not pleasing, and also these can be very structurally weak as well. So I was working on this model earlier, Brad, and these ribs were these ribs were big. So, and when I ran the plastics analysis on it, I had some major sink marks over here. You can see some light ones now. You see some light sink marks over here.
Yeah.
These were pretty big or pretty prominent. So making that ribs smaller right away before even reaching out to my mold maker, be like, okay, I can address this, and that ribs doesn't need to be that thick over there. I can make that change over here. I can do that analysis, and when I'm sending this to the guy, to the mold maker, these issues are not going to pop up.
Yeah.
There might be some other ones, of course, that are going to pop up from some things that we might not have addressed, but that's less than what we're going to run into if we didn't run any analysis on it. I always also say, Brad, analysis, like running these simulations, is not your last thing. Okay, you run the simulation and you go into production. You don't do that. Nobody does that, right? You run the simulations, you get closer to the one design that's going to be your final design. You run a couple of tests on that final design, make one or two iterations if you need to make it, and that's your final design. So you're not
obviously you want to eliminate as many physical prototyping steps as you can.
correct.
Sure.
Correct.
Okay.
So, this, so like I mentioned, Brad, plastics for me, I feel it's so underrated because the amount of time it can save. And I highlighted some of those time slots for, how it saves that time when you're going back and forth with the mold maker. And it's just not time, it's your peace of mind as well. Like, you rather be doing better things with your time than just emailing back and forth with your vendor. You want to be able to address these things.
Hmm.
So, I've addressed structural, I've shown you plastics, but Brad, there's so many other things, like, in our portfolio that we can,
Hmm.
take a look at, that, some multi-physics capabilities that we have, that address different scenarios, like that address different areas. And to show you, I'm going to quickly jump back onto my, one of the things that I have to work on. I haven't started this, but I just wanted to mention it to you. Once this loads, this crash test, where you saw the whole bowhead bike with the front bracket.
Okay. Okay.
See if I can open this again, and I want to show you what my next goal is, or what I want to do with that tool. What I'm trying to do is do two different things. First, do a crash test. So I'm going to be using the explicit analysis, the explicit solver on my, from my structural portfolio,
Hmm.
and running it into a wall. I'm just going to run into a wall. It takes quite a long time to set something like that up. You have to
Okay.
prepare your simulations accordingly. So perhaps that's for one of the next sessions or something
Okay.
like that.
So we might
But
need a part. I mean, you've already explored a lot of things where I think design level simulation, the kind of things that we think are like built into SolidWorks simulation tools, mm, you can do static, you can do you can do some vibration and things, but when it really gets hairy, you're saying this is where you want to go.
this is where you want to go, and I'm not just saying that. The industry says that, right? So the reason why industry says that, because what's behind all these tools, there's a powerful industry leading abacus solver that's
Okay.
backing all of this stuff up. Like, you don't have to listen to me, man. You listen to the abacus, so it's absolutely, critical in when it comes to, like, running complex simulations. Like, you have, other tools, but there's limitations. Or, of course, this is also going to have limitations, but the limitations bar has
Mhm.
been raised. Like, I've never been able to run a crash test study on a complicated assembly that's running into wall, or do a drop test, or understand the free surface flow. That's amazing things. So there's a lot of simulation capabilities that have been provided, but the goal is to connect how to use these into your workflow, or what are you working on that can require, or that can utilize these studies, and give you preliminary results, give you a solid platform to stand
Mhm.
on, and be confident in your results. You can't do that without, at a very early stage, without the use of these tools. Absolutely not. Like, or if you can, please, I would love to learn some other way where we are able to, kind of have that kind of confidence in our design, without having, multiple prototypes done, and without having, you know you get the idea what I'm trying
Yeah.
to say.
Well, and I think what I found was really cool too is that first off, all those different simulation disciplines, you're running them in the same environment. So it's
Correct.
not like they're not separate applications. They're just it's like you're just accessing different capabilities within the simulation environment.
Correct.
So
Correct.
it's not a bunch of different separate software you have to install. It's just a matter of like, hey, do I have HBO and Paramount Plus? I don't have to get two separate TVs to watch those. I just turn on different capabilities. So I like that modular aspect of it. But what else I think is cool is you were jumping around on some of these different tabs here on your dashboard. Um, I really liked how you were talking about how you can share that data with people downstream without them having to install anything. All they just use is their browser, right?
Correct. Correct. And yeah, like, whoever is on your team, in your collapse race, they have access to this. You give them access to this depending on what what level of access they require,
Mhm.
right? So if it's someone who just requires a quick view of the analysis and the results and things like that, you can give them this,
Oh,
right?
wow.
So you see what's happening over here,
Yeah,
Brad?
what's happening here? This is a lot of eye candy. What's going on?
Right. This is so. I love eye candy, right? I mean, simulation is cool, and we want to show simulation as a cool thing. Like it is one of the coolest things that have happened to me. So what you are seeing over here is a dash or is a sort of a tab that I've created to visualize all my simulation results. And I can fill a couple more in. It's up to
Mhm.
me how many I create. If this is too much for you, create 4, create 6. If you have 5 results, create 5, but you can have, a tab where you can bring all your results in one. And this, in my opinion, is a very, very powerful visual aspect that we can show. So you're seeing some displacement results. I can maximize any one of them and sort of change what I want to look at. Let's say if I want to take a look at one pieces instead, I can do those changes. um, I did want to show you some a cool. Like, remember I was mentioning the lattice design, and since it's asking me for logging again, I'm not
Yeah,
gonna
yeah.
bother logging in again, but
Yeah,
I can
let's
show
just
you
see
some
one that's
results.
finished.
Yeah, look at that. So I was able to create an experience content with the simulation that I ran, and that allows me to look at this the lightweight results over here. And
Mhm.
again, simple. We're just looking at a structural study. We're just looking at a von Mises stress result on this lattice structure. So
Yeah.
let me just animate that to show you what it kind of looks like. You can see how the stress is sort of distributing throughout the lattice structure over here.
Yeah, I mean, it looks like you could lightweight that a whole bunch more even.
Whole bunch more. So this was just a starting point. What I
Mhm.
can do with the lattice designer tool, Brad, is I can play with the size of the lattice. I can
Yeah.
play the shape of the lattice. I can create honeycombs, and I can create diamond shapes, and I can create a smaller radius, things like that. So
Yeah,
this is
that'll
this
be
is
fun. So
yeah.
you're gonna promise us an episode just on that at some point, right? Because I really want to see how you play with all those different variables.
Absolutely. I will absolutely do that. 100%. I will get you. But one of the things I want to not forget about, I was going to forget about this. I was mentioning explicit, right? Again, I'm just playing with the
Explicit is
results,
like what? Like breaking stuff? What is that?
breaking stuff, crashing things, and things like that. So
Okay.
I wanted to take a look at, how, if this swing arm runs into like a tree or something, how what happens. And I wanted I wanted to see, instead of a swing arm, if there was a lattice, if it's still going to be okay.
Yeah.
So again, I'm in much exploration stages, right? I'm just trying to see what these tools are capable of, what we can do. And you can see like how it kind of hits there, and then there's like some stresses that go through it. You
Yeah.
see
And
that,
what's
Brad?
our time duration on something like that? This is like on microseconds or something, isn't it?
Yeah, but of course, time duration in the sense, how much would it take to set this up and run this
No, I
study?
mean time duration of the event. These are
Oh,
like
yes.
super short duration events.
You can create a custom one, but this would be like I think I did like everything within 1 second.
Uh-huh.
So multiple iterations of 1 second, I believe.
Okay.
Yeah. So again, super
Wow.
cool candy, and I'm able to, I was so this down section I was keeping there for some flow results.
Mhm.
That one issue that I mentioned, where you have the big assembly and you've got the shroud up front. The reason why I wanted to have that was, one was crash test. The second, I wanted to run a fluid dynamics analysis on it. I
Okay.
want to see um, how how much air is like, what's the airflow around it,
Yeah,
because
aerodynamics. Okay.
aerodynamics of it, right? So there's a couple of reasons why, Brad. So this is an electric bike, and let's say if you want to take this bike to a long run, like let's say, I'm not sure what the battery life is for the for this particular bike, but I want to go for a longer run. Do you think if I have a more aerodynamic shape, also lighter shape, I will get more from my battery life if I'm going uphill, and I'm like, I'll be able to get a little bit more mileage?
Well, you'd think so. I don't know how quantifiable it is, but sure, let's go with it.
So a little bit, right? You're not working so hard against the wind.
Mhm.
So, but again, you have to compare that with what happens to the weight if add the shroud. So there's a few things you have to take in consideration. But that's what analysts is. That's what an FEA analyst does. That's
Yeah.
that's like a job every day, right? You have
Well,
a couple of different scenarios. You want to take a look at which scenario is the best, and sometimes none of the scenarios are good, but you have to pick the worst. Oh, pick the best of the worst.
best of the
So
worst. Yeah, I mean, I guess it kind of brings everything around from what you were talking about earlier as an um, well, as an engineer and as an analyst. As an engineer, we sit around and think about what if problems and solve those all the time. But if your only tool for validating those is a physical prototype, it limits what you can do, what kind of problems you can imagine, and then that therefore constrains your design. But I think what you were talking about at the outset was just the lack of tools. Well, what if you had the tools? And I think that's what you've given us a glimpse at here today, which is really, really great to see that there are all these different solutions. So Ron, hey, we're getting close to the top of the hour, but if you wanted to start bringing this back around, what are some of your closing thoughts about what your day in the life experiences and vis-a-vis these tools that you've discovered? How did that help you in your career as a production designer / analyst?
Oh, a great question. And I think it did wonders for me. And of course, like because I knew the tools, because I had experience in the tools, I kind of became the go-to guy for,
Mhm.
hey, is this going to work? And but you have to also understand, like, you have limitations. If someone is coming to you, be like, hey, please simulate dark matter for me. Yeah, can't do that, guys. So you have to know your tools. You have to know the limitations. But above all, Brad, what you need is that eagerness. You need the eagerness to actually jump in and be like, hey, guys, I know these tools. I want to be able to help. I want to be able to, address these problems that might happen down the road. So that has to come from within. Like, if you want to be an FEA analyst, yeah, you have the tools, but let's take on some projects. Like, ask your bosses to, like, hey, I want to go that direction. I want to do that. So, and perhaps that will be a good starting point of like incorporating, some base level tools and then kind of building up from it. So
Okay, that makes sense. So starting with basic capabilities and working your way up. That's always walk before you run. I guess that's always good advice.
walk before you run, and be humble. You're always going to run into people that know a lot more than you, which is
Mhm.
a great thing. Like, so with the plastic, like, give you an example for the plastics tool. Like, I know how to run the tool, but I don't have 30 years of experience as a mold maker in the industry, right? I'm eventually I might,
Mhm.
but you don't see that as I don't see that as a competition. I'm not going to be competing against, like, the person who's a mold maker 30 years. In fact, I'll be collaborating with them. Hey guys, I ran this study, this is happening, do you verify that, can you validate that? And that's how I see these tools being used. You have very, very powerful tools to address multiple different areas of simulations. But you also have to have the knowledge. What are you doing with the tools? Because the someone told me when I was learning simulation, garbage in, garbage out.
Yep, there's that.
So you want to be able to understand what you are putting in. What are you asking the software to solve? Is it replicating, or is it close enough to what you have in real world? That connection, once you make that, that's a good place to be.
Wow. Well, that's I think that's a great place for us to wrap up on the day too, with some good sage advice from your experience in the field, and not only that, your product expertise. We got to see some really cool things, and I loved how you tied that back to your experience in the medical device industry as well. So, Ronit, thanks for being a great guest here today on Live Design. And I'm definitely going to hold you to that lattice design, because I think everybody in the audience would be interested in seeing that down the road.
Awesome.
Yeah, and so to our audience, thanks for contributing to the chat and for watching this episode. And hey, before we say our goodbyes here today, I just want to give you all a heads up in the audience. Well, first off, I want to thank our folks behind the scenes. We have Andrew Gross, who's producing the episode, and we have Sean O'Neill, who's been running the chat and answering questions. So you didn't see their faces today, but they did a lot of the work behind the scenes to make the episode happen. So thanks for that. And of course, if you want to tune in to the next live streaming episode that we have next week, we have Sean O'Neill. You'll actually get to see him on camera this time and not just be behind the scenes, but he's going to be running a live stream episode, a little bit different format than we've done in the past. But this is just going to focus on our cloud services. And this is some of the new offerings that you may have heard about that have really just been out since about July. And this episode is all about just activating cloud services and getting started with those awesome new tools that started shipping with every new license of SolidWorks starting about July 1st. So that's going to be a great one to tune in on next Friday, November 3rd. So, subscribe and get notifications turned on for that if you want to be, if you want to join us in that next live stream. Hey, with that, folks, my name again is Brad Williamson, and it's been it's been a blast getting to interview my friend and my colleague Ronit here and get to see all these awesome simulation tools that we have. Thanks again, everybody, and we'll see you